Hello everybody and welcome back to another brainstorm. Today we're going to be talking about the alkenes. And this is part 2 of the organic chemistry series, so make sure you guys check the rest of that out. First of all, we're going to talk about what exactly are the alkenes, and then we're going to move on to talk about the 4 reactions of the alkenes. So let's get into it. Alright guys, so let's start off with what are the alkenes. So the alkenes are a homologous series of unsaturated hydrocarbons. So you remember from the previous video that a homologous series is a group of chemical compounds that all have the same functional group, therefore they behave in reactions in similar ways and have similar characteristics. We also mentioned what a hydrocarbon is. Remember that that's a chemical compound only made up of hydrogen and carbon atoms. And last video we talked about the alkanes, which were saturated hydrocarbons, but this time we're talking about unsaturated hydrocarbons. And what that means is that every carbon atom is not bonded to 4 other atoms. Now the alkenes also have at least one double covalent bond between their carbon atoms, a double CC bond. And the double carbon bond is their functional group, so essentially it's this double CC bond that enables them to behave in reactions the way they do and have the characteristics that they do as well. You'll also notice that all of the alkenes end in ENE. The ene sound, the same way that the alkanes end in ane, these end in ene. And for all of the alkenes, they have this general formula CnH2n, meaning that however many carbon atoms we have double the amount of hydrogen atoms. Okay, so these are the first 4 alkenes in the homologous series. We have ethene, propene, butene, and pentene. You'll notice that although these 3 follow the mnemonic monkeys eat peanut butter, we don't have methane. There's no such thing as methane. Why is that? Because you'll remember that we have a double covalent bond in all of our alkenes, and methane implies that we only have one carbon, and obviously that can't double bond to any other carbons. So if we start off with ethene, we know that anything with the eth word in it has 2 carbons, and so following this rule, it must have 4 hydrogens. Propene, C3 must be H6, butene C4 must be H8, and pentene, a bit like a pentagon, C5 must be H10. Now you can also see here the display formula for our first alkene, ethene. We can see that it's got that characteristic double covalent bond between the carbons. It's unsaturated because each carbon is only bonded to 2 hydrogens, and it does follow the general formula. Now practically alkenes are usually used in industry for 2 main things: alcohol production, and they can be made into plastics through a process known as polymerization. Alright guys, so now we're going to get on to the reactions of the alkenes, and we have 4 that we're going to look at today. First of all, we have the combustion reaction, and you'll remember from last video that combustion just means reacting something with oxygen. Then we have a reaction with hydrogen, and as the name suggests, that's just reacting it with hydrogen. Then we have a reaction with the halogens, and if you look at this periodic table here, the halogens are these group 7 elements here, and they usually end in INE. Common example is chlorine. It's important to know that these group 7 elements are diatomic. What this means is that they exist naturally in pairs, so for example chlorine will be Cl2. And finally we have a reaction with steam, which is just water in a gas form. So we're going to start off with the complete combustion of the alkenes. Now when we normally just burn these alkenes, this results in incomplete combustion. And you'll remember from the previous video that the difference between these two is that complete combustion is done with plenty of oxygen, whereas incomplete there is not enough. And you also notice that the chemical equation for complete combustion of alkenes is very similar to the complete combustion of alkanes, which we looked at in the previous video. So we react the alkene with oxygen, and this again results in carbon dioxide and water. So if we take our simplest alkene, ethene, that's C2H4, and react that with oxygen, we can see that this produces carbon dioxide and water. And if we balance that up, we can see that this is our complete combustion of ethene. It's important to note as well that because alkenes, when are burnt, generally incomplete combustion, they're generally not used as fuels, and we tend to opt for alkanes. Okay, so the second reaction that we're going to look at is reactions with hydrogen. The first thing that you'll notice is that we react alkenes and hydrogen, and this actually produces an alkane, the chemical compounds that we looked at in the last video. It's important to note that this reaction also takes place in the presence of a nickel catalyst and at 60 degrees. Now we're going to look at the display formulas to explain why this happens. So if we take our most simple alkene, ethene, we have the double carbon bond with 2 hydrogens on each, remembering it's unsaturated, and we're going to add hydrogen, which is diatomic. So when this reaction occurs, this double carbon bond splits open to form a single bond, and that looks like this. Then we have our pre-existing hydrogens, which stay the same, and then these two will join onto the bottom. And what you'll notice is that now this is a saturated hydrocarbon, which we knew in the last video to be an alkane. So when we started off with ethene and we added hydrogen to it, we finish off with ethane with an ane, alkane ending. Alright, so the next reaction we're going to look at is the reaction of alkenes with halogens, or group 7 elements. We can see that when we react an alkene with a halogen, we form a compound known as a dihaloalkane. Now we're going to draw the display formula to show how this works. So we're going to take our ethene with its double bonds and it being an unsaturated hydrocarbon, and we're going to react it with a halogen. For the sake of this example, we're going to use bromine. You remember that these guys exist as pairs and they're called diatomic molecules. So what's going to happen is, once again, the double carbon bond is going to split open to form a single bond. Our hydrogens are going to sit as they were, and then our bromine is going to come and bind to the bottom of this molecule. So we're going to have one bromine here and one bromine here. So hopefully now you can see what we meant by dihaloalkane. Dihalo meaning we've got 2 halogens, we can see the 2 bromine at the bottom, and alkane because if we didn't have these bromine it would have been a saturated hydrocarbon, i.e. we know that that's a alkane. And so because we reacted here ethene with bromine, the compound that we formed was dibromoethane. Dibromoethane. Okay, so the final reaction we're going to look at is the reaction with steam. You can see here that when we react an alkene with steam, we form a compound known as an alcohol. Now we haven't actually looked at alcohols yet, and we're going to do so in part 3 of the organic chemistry series, so make sure you guys check that out. But the only thing about alcohols that we need to know at this point is that they have the ending anol, A-N-O-L. In the same way that alkenes will have the ending ene, these guys end in anol. You can also see that this reaction is reversible. It happens at very high pressures, so it's reversible, and it also happens in the presence of a catalyst. So what we're going to do now is we're going to look at the display formulas to see how this works. So we're going to start off with ethene, C2H4, and we'll react that with steam, which we know is the same as water, H2O. And it's a reversible reaction that produces an alcohol. And the way it does that is these 2 carbon bonds, the double bonds, are going to split open to form a single bond. Our hydrogens will sit as they were with 4 hydrogens. And this is the important part. Our water molecule, H2O, this OH segment will sit by itself, and the H here will sit by itself as well. And will bind separately to the carbons. So on here we'll have an OH, and here we'll have an H. Now these two could be the other way around, it doesn't really make a difference. The only thing that we need to know now is that ethene produces the alcohol ethanol. So you remember that characteristic ending anol for alcohols and eth, because that's an ethene, it doesn't change. Alright guys, so we're going to wrap up this video by quickly recapping everything that we've learned today. So you remember that we've been talking about these molecules known as the alkenes, and they all end in this characteristic -ene word, okay? And we found out that the alkenes are unsaturated hydrocarbons. We remember that hydrocarbons are molecules that only have hydrogen and carbon atoms in them, and unsaturated meaning that every carbon atom is not necessarily bound to 4 other atoms. And that's in contrast to the alkanes, which we found last video to be saturated hydrocarbons. Now these alkenes are characterized with a double covalent bond. That's the functional group, and that makes sure that they react in reactions that the way they do, and they have the characteristics that they do. And this is the double CC bond, the double covalent bond between carbon atoms. We also know that alkenes in everyday use are used in alcohol production. You remember that with the reaction with steam that we went over. And they can also be used to produce plastic bags in a process known as polymerization. We also talked about the fact that all alkenes follow this general formula CnH2n, so that means that every carbon atom in an alkene has 2 hydrogen atoms. Now for our homologous series, you'll remember that the first 4 alkenes are ethene, propene, butene, and pentene, and you remember that there's no such thing as methane because we have to have this double covalent bond. Then we went on to talk about our 4 reactions with the alkenes. First of all, we had combustion, which was pretty much the same as the combustion reaction with the alkanes, in the sense that we produce CO2 plus water. Then we talked about the halogen reaction, where we produce these molecules known as dihaloalkanes. And then we talked about the hydrogen reaction, where we just produce those alkanes that we talked about in part 1. And then in the steam reaction, we produce these new chemicals known as alcohols, which we're going to come on to in part 3, so make sure you guys check that out. And with that, I'd just like to say thank you guys for watching. Make sure you hit like and subscribe if you want to see more videos like this, and be sure to check out the rest of the organic chemistry series that I'm doing, and I'll see you guys soon.